Assemblies made of metal are part of our daily lives. Components such as screws, bolts, sheet metal parts and many more types of fasteners undergo a variety of different production processes. To ensure continued reliability and compliance with quality requirements, manufacturing-induced embrittlement must be avoided. To monitor all production steps safely and reproducibly, uniform reference test specimens are required. Standards recommend using C-ring specimens for detection of material embrittlement. These move through all process steps alongside the manufactured components. Successive removal of test specimens after individual production steps ensures in situ detection of material embrittlement. The C-ring test specimens can be sourced from reference materials or user-specific materials. Strip stock, wires or pipes can be utilized. Depending on the application, a multitude of materials such as C75, 23 manganese B4, 42 chromium Mo4, 16 manganese chromium 5 and many more can be chosen. Material embrittlement can have different causes. Relevant processes include cleaning and pre-treatment, heat treatment and various coating processes. During pre-treatment processes for dephosphating, it must be ensured that the phosphate layer is completely removed. Otherwise, there is a risk of delta fluoride formation and possible material embrittlement in the subsequent heat treatment. In addition, there is a risk of so-called temper embrittlement in the annealing step during heat treatment. On the other hand, the production-related material embrittlement induced by hydrogen comes into focus during the pre-treatment and deposition of chemical and electrochemical surface coatings. Incorrect heat treatment can lead to so-called 300 or 500 degrees temper embrittlement. The resulting diffusion processes cause material embrittlement, for example in locations around grain boundaries. This can reduce the binding energy of the material and may result in critical component failure. Before and after the respective heat treatment steps, temper embrittlement is reliably detected. During testing, specimens are deformed into plasticity. The deformation energy is measured with high precision and observed failure rates can be compared with historical or empirical reference values. Hydrogen-induced material embrittlement occurs due to hydrogen entry, for example during pre-treatment processes. Operations such as pickling or coating generate a production-related supply of hydrogen which can diffuse into the material. The hydrogen dissolved in the material can later lead to critical material failure during operation. To reliably detect hydrogen embrittlement, tension testing is sensible as well. By mechanical deformation of the C-rings into plasticity, hydrogen embrittlement can be detected safely and reproducibly from a measuring time of 3 minutes. In addition, hydrogen permeation measurement can be used as a complementary analysis method. Here, hydrogen is produced either chemically, for example using a pickle, or electrochemically, for example in the form of a coating process, in a double cell. The resulting hydrogen is recorded by a user-friendly, patented measuring system and provides a detailed assessment of the manufacturing process. In addition to process monitoring, the testing equipment can also be used for process optimization. All process steps can be analyzed and optimized in detail. Consumption of chemicals, cycle times, and energy-intensive processes such as baking out can be streamlined. Energy and process costs are significantly reduced and future increases in CO2 pricing are counteracted. By using thermal desorption spectrometry as a supplementary analysis method, the hydrogen content in the material can be determined directly. The hydrogen trapped in the material is thermically dissolved and recorded using a mass spectrometer. By comparing the hydrogen content of components from different material states and process steps, a complete process history can be obtained. By using measurement technology from iChemAnalytics, you unlock complete process reliability, optimized quality management, and total customer satisfaction. Possible material embrittlement is prevented reliably, and expensive recalls become a thing of the past. And all of this while you make an important contribution to global climate protection.